So this topic is called units of measurement. This is objective 1A and 2A. That's because we'll be looking at four different things we want to measure. And this is first one is going to be mass. We're going to identify the measures and determine when to use these units. The question we ask is, what is matter? So everything that is tangible in the physical universe can be broken down into units that we call atoms. So let's consider this room. There's 7 persons in this room. They look a little bit comfortable to me, in my opinion. But suppose we put 20 people in the very same room. You think the level of comfortability will be the same? Looks a little bit more crowded. This is what we call it's a little bit more dense. So when we consider atomic mass, atoms work in a very similar fashion. Some atoms only have a few neutrons and protons. And the more nucleons that an atom would have, those are the neutrons and the protons, the more crowded that atom is. This is how we determine mass. So when we consider an atom, a denser atom takes up the same amount of space as one that is lighter, that has more things clustered on the inside. So mass is often confused with weight, and there's a reason that this is the case. Because the only place that we know to weigh anything on this planet is on this planet. So when we measure the mass and you consider the gravitational force, it's pretty much very consistent over the entire Earth. Now there are differences in altitudes, and if you go under the at the lower depths, but if you were to go onto the moon, an object's mass is the same no matter where it is. That mass is affected by the gravitational force, and then that can vary depending on where you are. So as you consider this, the mass for the same man is 70 on both the moon and the Earth, but the gravitational force is different. On Earth is 9.81 newtons. On the moon, it's only 1.63 newtons. So that means that this man weighs 687 newtons on the Earth, but only 114 newtons on the moon. Now, as most of us will not be going to the moon or any other planets, we can more or less say that mass and weight are probably the same thing. So when you hear the word mass, just know for scientific reasons, mass and weight is not different. But for practical reasons, mass and the weight probably almost the same thing. Probably are the same thing if you're going to consider it. So we have two different systems that we want to look at. First one is called the imperial system. And when you measure, we use ounces. Ounce is about the weight of a strawberry. Use pounds. The approximate weight of a pound is if you had a fire in your hand. And I'm sure none of us want to be lifting a car, but most cars weigh a ton. Not all, but most of them do. The conversion is if you have 16 ounces, you'll end up with 1 pound. You have 2,000 pounds, you end up with a ton. And the metric units or the metric system of milligrams, grams, and kilograms. The gram is the standard unit. If you have 1,000 of these milligrams, you will end up with a gram. I mean, if you took a gram, split it up into 1,000, you have a milligram. These are very small, about the weight of 1 grain of sand. Gram weighs about a sugar pocket. And if you wanted to know what a kilogram is, if you hold 2 pineapples in your hand, that should do the trick.